Consumers can be hard to please. They spend a lot of time looking for just the right product to meet a specific need. They want more choices in styles and higher quality at lower cost. Meeting those demands is key to your company's future. When it comes to imagining and engineering better products, how can you find an edge? One way is to create your products using needle-punched, non-woven fabrics. Engineered to a buyer's exact specifications, needle-punched non-wovens are transforming entire industries, giving free rein to the imaginations of product designers and very probably touching your life in ways you never realized. In North America alone, annual sales of needle-punched fabrics have reached nearly $1.5 billion. The reason? Needling allows the blending of different fibrous materials, each with its own unique physical properties. So a product designer can ask for a fabric with a very specific mix of properties, exact levels of strength, permeability, flexibility, softness or stiffness, moldability, or heat and fluid resistance. Needle punch manufacturers can generally deliver an engineered fabric to do the exact job required. Needle punching produces a highly uniform fabric. The lack of flaws and irregularities gives these non-wovens the strength to thrive in harsh performance situations. For instance, the great strength and durability of needle-punch non-wovens allows them to stabilize tons of soil and gravel in constructing roads, retaining walls, and landfills. Needled fabrics greatly increase the useful life of these projects. Needled non-wovens can be engineered to hold their shape even under high temperature conditions. That's why they're popular in roofing applications, where they withstand temperature variances of more than 100 degrees for up to 20 years. Needle punch non-wovens can be produced in many thicknesses and can be extremely moldable. Automotive designers specify needled and molded non-wovens for interior seating trim, floor carpets, kick panels, package trays, headliners, and trunk liners because they can be formed to follow the slopes and curves of an automobile's contours. They can also be cut to fit without concerns for fraying edges. Soft, flexible needled fabrics bring strength, durability, and sound insulation qualities to bedding products as wrapping for springs and mattress padding. Needling results in very regular pore sizes between fibers. This allows designers to create commercial filters with very specific air and fluid permeability for use in auto air and fuel filters, pollution control filters in power plants, or in high-tech medical filters. Needle punch non-wovens resist heat and keep it away from unwanted areas. For example, needled felts in automobiles between the engine and the passenger cabin protect passengers from engine heat. Aircraft and boats commonly use needled non-wovens for the same purpose. Needle-punched fabrics can also provide flame retardation in seating to protect passengers on planes and children on school buses. Needle-punch non-wovens can be designed to flex, drape, and bend smoothly, so they're appealing to consumers of apparel and home furnishings in fabrics like ultra suede. They can also be made to simulate the look of leather, and those athletic shoes you just bought may very well have needled non-wovens as man-made uppers and inside linings and insoles. Because they can add strength to fabrics like vinyls used in furniture and seating, needled non-wovens are in demand. Needled fabrics can come in many colors and textures, making them attractive for high-performance indoor and outdoor carpeting and designer vertical blinds and pleated shades. They also provide padding and backing for most plush carpeting. Needlepunch products can be used to replace heavier and thicker metal carrier plates in ovens for chemically or thermally treated parts. Their thinner and lighter weight advantages allow more components to be processed at a lower cost to the parts manufacturer. Not so common cutting-edge uses are seen in transportation and aerospace. Carbon fiber needle-punched composites have been used for more than 25 years for exhaust nozzles for rocket motors and as structural components in the space shuttle's external tiles. In these applications, the needled nonwovens deflect the tremendous heat generated. Another growing use for needle-punched carbon composites is in braking pads for commercial aircraft, Formula One racing cars, and high-speed trains. The great versatility of needle-punch nonwovens has already placed them in hundreds of applications, from those that are as simple as the felt tips of marking pens and hammer felts for pianos, to cutting-edge, high-tech applications in aerospace and braking. As fabrics with the versatility to be designed to meet almost any need, they are remarkably responsive to the exacting needs of creative product designers for companies in dozens of industries.
INDA, the Association of the Nonwoven Fabrics Industry, advancing engineered material solutions. Find out more at inda.org.